Last month I built an Arduino based reaction timer game, which allows you to challenge your friends and family to see who has the fastest reaction time. We managed to get a few times around 160 milliseconds, and we've seen videos of people who can get down to 120 milliseconds, but now I wanted to see how fast an Arduino can react to the same game. I built a simple setup with an LDR to detect the light emitted by the game's LED and a servo to push the button. I also included an LED so that we can see if there's any delay between the Arduino telling the servo to move and the servo actually pushing the button. I've put links to the components you need in the video description. I connected the components together using a few strips of ribbon cable and some header pins. I then found a plastic base which was the right height to mount the servo on so that it could be positioned just above the button. Now let's have a look at the code. We start by including the servo library to control the servo. We then create a servo object called react and create a variable to store the value read from the LDR. In the setup function, we set the servo pin number and then set the LED pin as an output. Then set the servo position slightly above the reaction button. In the loop function, we read in the LDR sensor level, then compare it to the light set point. If the measured level is greater than the set point, we then turn on the LED and then move the servo downwards to push the button. We then wait 400 milliseconds for the servo to move and then move the servo back up for the next push and turn the LED off again. I've also included a serial monitor printout of the sensor value, which is used initially to measure the game's LED set point. You'll need to run the game and see what value is measured by the sensor when the reaction timer's LED is on, and then update this value in the code accordingly. If we upload the code and then open the serial monitor, we get a stream of input values read by the sensor. Now press the button on the reaction timer to start a game and look out for the change in values when the LED comes on. You can see in this example that we get a reading of around 775 when the LED is off, and it then goes up to around 830 when the LED is on. We can now go change the set point value to a value just above the off value, so that it triggers a servo movement as soon as the LDR starts to register a change in light. You should also comment out the serial communication for the final version, as you want the code to be as quick as possible. Let's upload the code and see how quickly it can react. Press the button once to start the game and then quickly position it under the reaction servo. For the first run we get a reaction time of 54 milliseconds, which is pretty quick considering I have to wait for the servo to move to push the button as well. I tested it a couple of times like this and consistently got around 50 to 60 millisecond reaction times. Watching one in slow motion, you can see that the LED comes on really quickly after the reaction timer's LED comes on, but there is a bit of a delay in getting the servo to move. Looking at the individual frames, I calculated that it takes about 8 milliseconds for the LED to come on after the reaction timer's LED. The servo then takes around 55 milliseconds to press the button after this. I then tried to see if making it darker around the LDR with some tape would result in a faster response time. It didn't really make much of a difference. I also tried disabling the LED, so the Arduino just had to move the servo. This improved the reaction time by almost 10 milliseconds, so that I got times around the mid-40s. So from this test we can see that an Arduino can respond to an external light source in under 10 milliseconds. The servo movement takes up most of the reaction time. There are ways to further improve an Arduino's response time by using direct port manipulation, but this is probably not going to make a significant difference in this example, as the delays in the LED lighting up, the LDR responding to the light, and the second LED lighting up is likely more significant than the amount of time the Arduino takes to respond to them. Thanks for watching. Remember to like this video if you enjoyed it, and subscribe for more tech and electronics projects, tutorials and reviews.